Today we're going to be defining distance versus displacement. So say that you have this lovely car here and you're driving towards the stop sign. And let's say that it's 100 meters between you and the stop sign. Then as you're driving towards that stop sign, you notice your friend, that guy. He is waving to you and he wants you to stop for him. So you've already reached the stop sign at this point, so you decide that you're going to back up until you meet him. So you back up 10 meters to get where your friend is. Alright? Now, how far are you from the stop sign at this point? Well, you're between where you started and where your friend is, right? Which would be 100 minus 10, so that's 90 meters. But the thing is, you traveled further than that 90 meters, didn't you? You traveled all the way to the stop sign and then back. So this is where the terms distance and displacement get really important. Distance is how far you've traveled total while displacement, that is how far you are from where you started. So, when you have this car example, you've driven to the stop sign and then you drove back. So you drove that 100 meters and you also drove that 10 meters back. So in total, in this example, your distance is 110 meters. But how far are you from where you started? Well, in that case, let's take a look at how far your car is from your friend. In this case, you're only 90 meters away from where you started. So in this case, your displacement is going to be less than your distance. Now let's take another example. You have your house, a park, and the school. Now every day, instead of walking straight to school along a diagonal line, you actually go from your house to the park, then you go to the school, and you take your time about it. So let's say that it's 3 kilometers, which would mean you'd have a heck of a long walk to school, but you never know. So 3 kilometers to our park. Then from our park to the school, it's 4 kilometers. Okay? So now in this case, how far do we actually walk every day? So in this case, our distance would be 3 plus 4, so distance would be 7 meters. But is that actually how far you are from the school? No, because now you draw a straight line between you and the school. And let's imagine that this is a 90-degree angle. So if that's a 90-degree angle, then this becomes a 3, 4, 5 right triangle, right? Which is one of those special kinds of triangles. So if we know that this is 3 and this is 4 and this is a right triangle, we know that this has to be 5 kilometers. So 5 kilometers. Now, would this be distance or displacement? In this case, since it's the shortest distance between where you started and where you end up, this winds up being your displacement. So, another way to think about this is, and let's move this back just a hair. Here we go. Alrighty. So another way to think about this is if I'm starting here by the board and I run up to the computer and then I run over here and then I run somewhere where you can't even see me, back to the board again, back over here again, then over in front of the computer, hi, then I'm back over here, then I'm back to the board where I started. How far have I traveled? What's my distance? My distance could be any number depending on how far around I went. I could take a flight of the bumblebee kind of path, and I could have taken a very long distance. But what's my displacement? My displacement, since I wound up where I started, is going to be a big fat 0 because I haven't actually gone anywhere from where I started. So my displacement is 0. Even though I don't know about you, but I just felt like I ran 5 miles, my displacement is still 0. Alright, well hopefully this helps you guys. Let me know if you have any questions, and I'll try and put up some more videos on velocity once we get started into that.